So let's start, shall we? It's taken us this long. We're finally going to begin motion. You can draw one of these, by the way, and we're going to fill it in a second. Motion. Actually, the topic is not really called motion. It is called displacement, velocity, and acceleration. But that's a bit of a mouthful, and it really is just talking about things that move, right? Hence motion. Bless you. So a lot of people don't like this topic because they're like, I didn't choose physics as a subject. Like, I didn't choose it for the specific reason to avoid all of this rubbish, okay? And now you're telling me I have to do it. And even if you drop down to 2 unit instead of 3 unit, you still have to do it. The only way you can get out of motion is to do general maths, actually, which you cannot do at this school. You'd have to do it. Yeah, no, sorry. You can do it by distance ed, I suppose. But then you'd have to deal with, like, annuities and... Actually, the series and sequences, believe it or not, the series and sequences in general is a lot worse than it is in 2 units. Anyway, I digress. We have to do motion, okay? And I want to try and get across the fact that physics and maths, right? That's what my 2 circles are. Physics and maths, you can't avoid the fact that they're intertwined, okay? But to help you wrap your mind around how what we're doing is not physics, is emphatically not physics, let me try and explain what the difference is, okay? Physics is a science, okay? And strictly speaking, maths is not, okay? Maths is closer to philosophy than it is to science. The reason why is because how do you know something scientifically? Like, what is the scientific method? It's about experiment, right? It's about experiment and observation. Okay? So, everything in science is about, can you look at something? Can you repeat it? And we're thinking about like things in the actual world which we can look at, okay? Now, instead of experimentation, right? When you're thinking about maths, how does maths work? Well, rather than, I said it was like philosophy, right? You're just trying to think up how something works, or how it fits together, or if there's a pattern. You're almost trying to make it up, right? As opposed to, I'm watching something do something, right? And I'm trying to get its pattern from watching it. As opposed to, maths is all up here, right? It's all the things that we do in maths are all fabricated. They're not real. There's a man and he's investing money and there's no real man that you're watching and observing. You're making it up, right? So instead of experimentation, I would call this imagination, right? None of it's real, okay? None of it is, well, your numbers are real. But anyway, that's right. The cake is a lie, okay? So, experimentation, observation versus imagination. Now, in the same way, right, what you're thinking about in terms of physics is natural phenomena. If it can't happen in the real world, physics is not interested in it. Right? Some things that we don't think could exist, do exist, and because they're in the real world, like say black holes, right? You can't see a black hole, but you can see its effect. It is a natural phenomenon, so that's why physics is interested in it, okay? Whereas maths, what does it deal with? It's not looking at things in the real world and trying to look at their patterns. It's about imagining things, particularly about logical connections and relationships. Okay? How does one thing fit to another? Rather than getting there by observation, you're getting there just by logic. Okay? Now, as you can see, there is an overlap, right? Physics and maths do sit on top of one another, and you can't do one without the other, and it's rather silly to think of one without thinking about how it relates to the other. So motion fits right in between here, right? Motion is the overlap between them. But can you see that physicists and mathematicians they approach motion in 2 very different ways? Okay? So we're going to approach it from the angle of equations and calculus, right? Okay? Well, if you got an equation like this and you differentiate, you integrate, what happens? What does that mean? Okay? Whereas in terms of motion, we're thinking about observations. We're like, well, this thing, the light from this star seems to get brighter every now and then. Like, why is that, right? So it has to do with the motion of, say, a planet in front of it, which is lensing the light and so on and so on, right? So, coming from different directions, okay? But by the way, this is not the first time you've actually looked at things which relate to physics, right? Earlier this year, we were looking at rates of change. balloons that got bigger or things that change in temperature. That's physics, right? Except obviously we start with an equation in our imagination, something which, it exhibits these characteristics that we just make up, versus, well, here's a thing, let's measure it. Okay, get a thermometer and stick it in. Okay. And later this year, we're going to get onto one more. I mean, this is not exhaustive list, but you've probably thought about this already. The topic that's called exponential growth and decay, right? Which is about populations, but it's also about like radioactive stuff that whittles away because of its half-life and all that kind of thing. We usually think of that as a domain of the physicists, right? Which it is, but it's also something that can just be thought of purely mathematically. Okay. So if you want to put it one more way, this is practical, and this is theoretical. The words we use, or the words that universities would use, is that this is applied. They would actually call physics applied maths, or they would call this pure maths. Okay? So that gives you an idea of how these two relate to each other. Okay? Does that make sense? So I hope that kind of wraps your brain around how these two relate. And relax, we're not going to be doing all the physics stuff. For instance, by the way, ironically, and this is what I mean by physics can't work without maths, right? You have all of these equations. Hands up, who does physics? How many of you do physics? Okay, right. So you guys, thank you, hands down. You'll have learnt all these equations about forces and mass and velocity and all that kind of thing, right? Like ut plus at squared and all that. We don't use any of them when we're thinking about motion from a mathematical perspective. Okay? So in fact, they're not valid to use. You can't like quote it and say, well, this is self-evidently true, even though it sort of is. It's true because of observation, right? And so since it's coming from that side, that's why we don't deal with it from a mathematical angle. Okay? So just to preempt, because whenever I teach motion, people always ask me, the physics students, they're like, this would be so much faster if I could just use the result that I already know and not have to differentiate and prove it from scratch. Well, the point is, we're trying to approach this one idea from another angle, from the mathematical angle. Okay? So that's why we don't use physics equations.